Right, so we come on to nano antennas now, which have been developed, which work inside your body. I'll just read this. A requirement for nano antennas is simultaneous wireless information and power transfer. Since electromagnetic waves carry not only information but also energy, antennas capable of converting an EM signal into a direct current using a ultra-high-speed rectifying diode are required. Rectifying antennas, or rectennas, based on carbon nanotube arrays have been proposed since the discovery of the unique antenna capabilities of carbon nanotubes in 2004. In 2015, Kohler et al. Provided the first demonstration of optical rectification accomplished using a forest of vertically aligned carbon nanotubes which act as nanoscale antennas with excellent absorption properties. Carbon nanotube insulator metal tunneling diodes fabricated on top of the array are ultra-fast rectifiers that generate a direct current. The achievable energy conversion is approximately 85% efficient. Graphene nanoribbon-based nanopatch antennas and carbon nanotube-based nanodipole antennas around 1 micrometer long resonate in the band 0.1 to 10 terahertz. Right now, so this is something which I've looked at a lot of these papers on intra-body communication systems, and they all come up with that frequency band range. Yeah. So this is, you think of 5G, you think of 29 gigahertz, right? So go up to 1,000 gigahertz, or, well, 100 gigahertz, let's say, which is 0.1 terahertz. So we're talking something 10 times faster than 5G and above. And the reason why that they're operating so fast is because they're so small. Their resonant frequencies are in the terahertz band. Now, they've developed all sorts of techniques. So just to try and explain it, you've got a number of things in your body, spread around your body, which need to communicate with each other, like a mini wireless network inside your body. But the waves are going through the skin. The electromagnetic waves are going through your skin at terahertz frequencies, and they've developed these nano networks that will fit inside people's bodies. It's all fairly new to me. It's the fact that they've developed discrete wireless networks that can fit inside your body working at terahertz frequencies. And it's all based on graphene. Graphene bow tie antennas with 2 triangular sections. The thickness of the antenna is 100 nanometers, and nanodiodes made of graphene located in the middle of the whole area rectify the AC flux to DC. Plasmonic graphene nanoantennas with a geometric diode such as bow tie can also collect energy from the infrared spectrum, which guarantees a constant flow of energy. So this is one question that a lot of people have. They say, well, okay, where's the power coming from for these systems? And they're self-powered through these things called rectennas. Bow tie nanorectennas take only 6 milliseconds to charge a nanocapacitor rather than 6 minutes for a carbon nanotube array. Graphene nanomesh could act as a capacitor. So capacitors can store energy that can run these quote-unquote circuits. Rectennas can operate in a matrix or array. The approximate output power of a single rectenna is 0.11 nanowatts. More elements connected in series can increase the production of current and power. So people might ask, well, what the hell is this used for? Let me just give a quick example to try and put into context. Let's just say that you've got nanotechnology in your body, and you've got biosensors in every single one of your 80 organs, right? And they are then going to communicate whatever they find in those organs to a central wireless network. So potentially you could have an automata which knows what's going on in every single organ in your body, and that information has been harvested and then possibly sent out to the outside world. And the same with the brain. Because Andersen reckons that the systems are split into 2 distinct areas, one monitoring your bodily system and the other one specifically for your brain. Okay, so you think there's evidence of antennas, and I think this is quite strong evidence, in my opinion, with the antennas that Mick Andersen has identified.
Yes. Well, so I mean, they had 2 options in the literature for antennas they could use. They could usually use arrays of carbon nanotubes with these metal insulator metal diodes to rectify the current at the top of them, or they can use these bow tie antennas, which have the a MIM, typically a MIM ultra fast rectifier in the centre between the two elements of the bow tie, the triangular sections.
So I can show an image from one of Mick Anderson's paper at this point, David, where he actually compares an image from scientific literature showing a bow tie antenna with one of Dr. Pablo Campra's images, and it is pretty similar.
Yeah.
So this image, this Pfizer image, 14, number 10.
We've got some fractal structures there. Now, in that image there, there's another option for antenna, which is a fractal-based antenna, and there are papers describing these, fairly recent papers, and they describe the uses of fractal antennas. There's 2 or 3 essential benefits of fractal antennas. One is multi-band, that is that they can concurrently transmit and receive on different frequencies. And secondly, they can cover a much longer, bigger range of frequencies more easily because they've got multiple antennas. And thirdly, they require fewer, I hesitate to say electronic components to control them, but they're simpler in terms of components.
It can be made out of one piece.
That's right, one piece. And also higher gains in the sense that they can be more directional, but in many ways they also respond to radiation from all directions. They're sort of omnidirectional, perhaps more so than some of the other antenna designs. Also in that image, I just would note on the right-hand side, we see a carbon nanotube straddling a chip, which is a feature which we should take note of for later.
Right, yes.
Yes, there is there.
So it looks like we've got some automata connected to a wire, which... all right.
And the other thing I would say is that only some of those, what I think would be blobs of hydrogel, have got those fractal structures on them. Interestingly, others don't. And you'd have to ask the question why that would be.
Right. So we've mentioned self-assembly before, just to try and spell out why that would be needed. If you want to install something in someone's body that will fit inside a vaccine and go through a needle, the components have all got to be absolutely microscopic. They've got to be tiny, and you might want something that's actually larger than that. So one solution is to inject it, and then those parts then self-assemble, which sounds incredible, but there are a lot of scientific papers being written about this.
That's right. Well, there's 2 elements to self-assembly. One is in a manufacturing process. So a lot of the papers do talk about self-assembly in the context of manufacturing nano devices, where conventional lithographic techniques, they're not really capable of doing it anymore. That's the way, for example, that you would etch out silicon into transistors. Well, when you get down to the nano level, then that becomes very, very difficult. So instead, when it comes to self-assembly, they try to look at how the biochemical molecules and whatever, how do they self-assemble? And they're trying to, in many ways, follow that method
so
as
well.
well.
To mimic biology.
Yeah, they are.
And they use DNA as the core tool to get something to self-assemble.
Yes.
Right.
Yeah.
All right. Yeah. New approaches rely on the use of nanoscale templates made of synthetic or biological materials to leverage biology with its inherent self-assembly capabilities. Bottom-up fabrication exploits the intrinsic properties of atoms and molecules to direct their self-organization. Right. DNA origami is a technique that uses hundreds of short DNA oligonucleotides to fold a long single-stranded DNA molecule, which is called a scaffold strand, into various designer nanoscale architectures. The DNA structures are 100 nanometers in diameter and approximate desired shapes such as squares, discs and 5-pointed stars on the 100 nanometer sized DNA shapes defined by raster fill. DNA's 3D double helix structure gives more advantages than other materials in guiding nanoparticles to 3D ordered assembly as well as 2D. All right. So it goes on. For example, the DNA scaffold molecule provides the address for the precise localization of semiconducting SWCNT field effect transistor. DNA origami has dramatically improved the complexity and scalability of nanostructures, and with its high degree of customization and spatial addressability, it provides a versatile platform with which to engineer nanoscale devices that can sense, compute, and actuate. So you think some of the images provide evidence of self-assembly, some of which we've already looked at. So this one from Carrie Madej, I think,
yes,
4005, what's that one showing, David?
Well, one of the techniques, if you like, the basic techniques to kick off, this is what Mick Anderson has proposed, is that they use a technique known as teslaphoresis, which is use electromagnetic voltages, if you like, a voltage field, to direct the particles into basic structures, for example, chains. And I think in this image here, we're going to see that these particles are being directed into a chain. Now, this is a technique which you can see them using in a manufacturing plant, but this is actually taking place on a slide under a microscope.
Right.
So I think that there are other methods that there may be that they can achieve the same as teslaphoresis. I mean, you can watch videos on YouTube from Rice University showing teslaphoresis, which involves a Tesla coil to generate a very high voltage near field.
So you've got an image from Reutling in there that you think might show evidence of self-assembly, which looks a little bit like an old-fashioned mobile phone.
Yes, well, it starts off like this. Now, this is the first time that we saw something that might resemble some of the images we see later. Now, I wouldn't say it does look exactly the same, but that, according to Dr. Axel Boland, became the next image.
Right. I mean, this does look like some of Canberra's other images.
Yes, it does, yes,
right?
yeah.
So we've got two completely independent studies there showing similar structures.
Yeah.
So that the device that we see there in that image, 8003, became 8004.
Well, he said 3 months later.
3 months later.
Now, I suspect that joined up with other components to create that. I don't imagine he monitored the whole thing, but you'd have to ask him. But we're seeing these sort of quadrangular structures with these surface features, which in this image look more like a sort of scoring on the surface than perhaps later images, but it's very similar. And that's the first time we saw anything like that. I mean, when I first saw that image, it was quite surprising to see that.
Right. So we think the more sophisticated images might be evidence of something further down the line in terms of its self-assembly.
Yeah, yeah.
So 9004, what we're looking at there.
Right. Well, this comes from the AstraZeneca, and I think this is the Austrian study, and they noticed these chains that were forming. Now, I'm speculating that these chains. I mean, this is complete speculation, but we know earlier we mentioned arrays of these antenna, these rectenna, or arrays of anything that could sort of generate power, really. I mean, they could be piezoelectric, zinc oxide type generators. That's mentioned in the literature quite a lot as a method for powering these systems. But if you wanted, I mean, it's worth just discussing this, but if you wanted to create significant amount of power, for example, for communicating outside the body, which would need somewhat more power than the intra-body network, then you might want to create arrays of power generating devices linked up in series like this.
Right.
So it's just a speculation because I don't know what else they'd be used for.
Right.
If we look at the next slide, this is a close-up image of that. So, I mean, they look fairly regular, those structures. So they're definitely of the same type, I would say.
You could be trying to create a wire of some type.
Well, it could be a wire. It could be a wire.
What do you think
yeah.
more, it could be to do with
Well,
power?
I'm just speculating because I
Right,
think they
right.
need to create, and then they have mentioned they need to create arrays of these things to create power. So I just thought I'd throw that out there, and
Right.
that's the nearest image I've seen to anything that might be that. That's
Right.
all. And the next image is the same. Right. So then we move on to this is the Argentine study. So what we've got here is some self-assembly. Possibly this is similar to the Tesla phoresis process, but something has basically drawn these elements into this chain.
Right. Okay.
Clearly, I think we could say that's self-assembly because that's
Right.
didn't come out of the needle, I don't think, like that.
Right. And 18002.
Again, in the Sputnik, again, I think we can see the process of self-assembly going on there. But there's some slightly different sized objects, and these remind me of something, again, we'll see in a bit when we talk about sensors and actuators.
Right. Okay.
Well, again, we can see in the AstraZeneca, again, a structure that appears to be self-assembling. I would say that rather than it coming that way.
Mm-hmm.
I have no idea what it is, really. And then the next lighter image there.
Yeah, just keep going.
Keep going. Right. And again, a very square-like structure with perhaps either a sunken or a raised area in the middle of it. Another structure, obviously from a number of combined structures, I think. And again, looking at these images just to see how many of them there are. Again, another image there with sunken areas. And now, yes, another sort of oblong structure there. Another sophisticated construction. Okay.
In these later images, you've got the chip-looking objects as well as carbon nanotubes.
Right. So what we've got here is we've got a carbon nanotube that seems to have some relationship with the chips.
So this is from another study. You've got an image.
Yeah, I've just wanted. This is from Dr. John B, and I'd just point out that he also noticed a similar kind of construction in that top right image to some of the images that we saw from the Argentine study. Almost a ribbed type structure,
Right.
but he noticed that.
Okay. These components, if you like, they're in a substrate, as you mentioned.
Yes,
They're in a fluid, right?
Yeah.
So is this what they call hydrogel?
Yes, well, we suspect this is hydrogel.
Right.
So what's been noticed is that as the samples dry out under the microscope, any sort of water or whatever evaporates, and we're left with this sort of substrate, which appears to, when Dr. Camper did his Raman spectroscopy, he noticed this 1450 peak, which comes out of the spectroscopy, and Mick Anderson did an analysis where he looked through the scientific papers to try and find out what that 1450 would correspond to.
Mm-hmm.
And in my opinion, the most likely of the candidates he found was polyvinyl alcohol hydrogel.
Right.
Now, polyvinyl alcohol crops up in a number of places here. For example, being used to coat carbon nanotubes to make them more biocompatible.
Right.
Also, it helps in the process of turning them into electrodes as well.
Right.
So we can speculate maybe that the substrate is maybe polyvinyl alcohol. There are a couple of other possibilities, but this polyvinyl alcohol can serve perhaps a number of functions. One of which is to help with the biocompatibility of this technology, but also because it tends to have electronic or electrical capabilities. It might also help in the self-assembly process,
Right.
and also as perhaps another mechanism of communication between these different components.
Right. Right. And there are some images. For example, number 217. Clearly, it looks like there's a blob of something that the chips are within.
That's right.
So you think that's could be a hydrogel?
Gel blob, yeah.
Right.
We tend to see a lot of them sat in these blobs.
Right.
So and then from the Argentine study in the Sputnik again, this is another hydrogel blob. There's a chip sat in it, but that substrate does. I'm be fairly sure it does play a role here.
Right. Another component of in vivo nanotechnology is are sensors and actuators. So if this technology is going to interface with the body, it needs to be able to sense what's going on in the body and make things happen in the body. So that's basically what we mean by a sensor or an actuator. And a node is something which takes information and then sends it on its way. So I'll just read this. A generic nanosensor node includes an energy harvester, a communication mechanism, some processing logic with nano memory, and a module for sensing and actuation. Nanodes include graphene quantum dots, swimmers, or graphene nanoribbons. These have all been observed in blood samples from vaccinated people. The sensor is able to detect an optical, biological, or mechanical event with high sensitivity and converts the response to an output electrical signal. A carbon nanotube can be used to build a field effect transistor whose on-off threshold voltage depends on the carbon nanotube's physical properties, such as shape and temperature, or the presence of a specific type of molecule. The large surface area and the excellent electrical conductivity of graphene allows rapid electron transfer that facilitates accurate and selective detection of biomolecules. The actuator responds to an input electrical signal to perform the administration of drugs or perform neuromodulation. Graphene oxide and R-graphene oxide are used for drug delivery. So within this nanotechnology, we've got systems that can carry something within inside it, and then on a particular trigger or a particular instruction, it can release a drug into a specific part of the body. So this is standard drug delivery techniques. So we don't know that that's not even incorporated into the vaccine. There might be some actuation in there.
Well, these sort of artifacts are, present in the vaccine. So we don't know what they're for, but we can identify quite a few, I think, of these actuators and sensors, but more actuators actually than sensors.
If you're not getting this, folks, this is the crime of humanity. This is the biggest crime ever being committed against humanity that we're talking about here. We're talking about the introduction of some sort of communication stroke actuation system into the human body without the permission of the world's population, against their wishes. I can't overstate the importance of this, what we're discussing now, and this is where the debate needs to be. Not talking about COVID, not talking about prime ministers' parties, talking about what is the poison, what does it contain, what's it for, how does it work? Because most scientists haven't bothered to look inside a vial, right? What we're showing you is what the weapon consists of. This is where the debate needs to be. And if you've got this in your body, you need to think carefully about why you allowed it in your body and what is really in your body and what it's going to do to you. And what are you going to do about it? Are you just going to sit there and accept it? That you've everything that you've seen so far, that you now know is in your body. I haven't shown my images yet. We'll come on to those. Anyway, so you think that there's evidence shows that there's actuators within the vaccine, which is something which is going to change something in your body. In other words, it's going to, at some point in time, it's going to introduce an effect on either your brain or your organs or whatever it might be, which could be a release of a drug, or it could be an electrical stimulation, or it could be a physical actuator that stops blood flow or that causes a brain hemorrhage. It could be anything, couldn't it?
That's right, yeah. I mean, For sure. I mean, we've already discussed carbon nanotubes, which, if you look at the first image we're looking at here, you can see on the top left a pair of carbon nanotubes. But if you look at the image on the bottom right, what you've got there is a carbon nanotube that's got a couple of components attached to it. So what you might surmise from that is that those two components attached to it might be what they're going to activate with.
Right.
So because of this affinity for that carbon nanotubes have for biological molecules and other elements, then they're ideal for transporting drugs to different parts of the body. So at the very least, the carbon nanotubes can serve that function. But
Right.
as we'll see, there's some other other types of actuator that
Right.
we found as well. So go to the next.
Yep. So 7001.
Right. So for that previous image was Dr. John B looking at the Pfizer. This is Dr. John B looking at the Moderna. And what we see here is what have been described as colloidal beads. Now what these are swimmers. So what they're designed to do is to swim around the body with a sort of flagellar motion. And they're made up, we think, of a carbon nanotube which attracts these sort of spherical, perhaps magnetic beads, which are laid out along the length of the object, perhaps with a larger bead as a head, if you like, at the start. And this is what looks like being assembled here in this image from the Moderna. Right, so these have a sort of swimming motion. This next image shows again the same kind of constructs taking place in the Moderna that Dr. John B showed. And also, I'd just point out in this image that these circular objects as well that you see round about, which we'll come on to, they're also involved in this. In fact, we'll come on to them next.
Right. So 11001, very different, striking image now.
Yeah, this is an image Dr. Zondre Botha presented on the Stu Peters show. And these are microbubbles, which again can be coated with that polyvinyl alcohol I mentioned earlier, which gives them a sort of magnetic quality as well, which allows them to be directed electromagnetically. Now these microbubbles are specifically in the literature for drug delivery. So these are your classic actuator. So these are injected into the body, guided perhaps using ultrasound or using electromagnetic frequencies to a particular part of the body, and then using a particular frequency they burst and deliver their payload.
Right.
At that point, there's a number of images there. I mean, they have this very regular sort of hexagonal structure, so they have 6 potential connections, so they can be formed up into these arrays as well as operating independently. And then...
And Camper has found something very similar.
That's right. So he found them in the AstraZeneca and the Pfizer. I think these images from the Pfizer.
Some people might say, well, hang on, is that not the nanolipids we're looking at?
Well, these are far too big for nanolipids, because nanolipids are nano by
Right.
definition.
Yeah.
These are in the micro scale. So
this is, you know, we're not mistaking this for what should be in the vaccine, are we?
No,
This is something completely
no,
different.
no.
This is potentially, there's a payload of drugs within the vaccine that could be just sitting inside somebody's body that hasn't been released yet.
That's, well, some people have hypothesized about what that might be about. Yeah, what you've described might well be the case, that they're sort of dormant, waiting to be released.
It could be some drug that they've decided is going to help anyone who gets cancer, but again, it could be something that just terminates your life, or well, whatever they've decided to put in there.
That's right. Yeah. Okay. So we're back to here with the carbon nanotubes, but in this case here we've got carbon nanotubes with crystalline structures on one or both ends. Now these crystalline structures present even more of an electrode capability to the carbon nanotubes, which renders them even more of a sensor or potentially an actuator as well. So, but we've seen quite a lot of these sort of images, so if we go down, we'll see more from Campra, a close-up there of this sort of crystalline structure attached to a carbon nanotube.
Right.
And again, we see this bluish one. Again, I don't suppose we can say it really is blue, but I wouldn't rule out that there's colour involved. But again, on each end it's got apparently some kind of crystalline. It certainly reflects a lot of light under the microscope. And these are, you know, sort of functionalising these carbon nanotubes for probably a particular use.
Yeah. And just to reiterate, in the scientific literature, the carbon nanotubes are often associated with brain interfacing, and connecting to individual neurons inside the brain, or even creating an entire mesh over the existing brain tissue.
They replace axons, really, in the literature, so they actually short-circuit axons in the brain. They can be used for that, because I believe they're more efficient than the natural axons, which would connect the neurons normally. They've talked about that in their own literature. I'm not making that, you know, that's in their own literature. Yeah. So this next image here is more the sort of colloid structure, where you have these spherical components being added to the head and to the body of carbon nanotubes to create these swimmers. They have this sort of flagellar type tail effect where they can swim like sperm or something like that.
Mm-hmm.
Again, another image showing the same kind of sort of construction in the Pfizer that Campra showed. And then another image, the same. And then this image here, again, it really just suggests a swimmer with a head-type structure. I mean, some of these structures can actually morph, so we'll come on to that in a bit, but you know, you could say there that you've got a tail-type structure for swimming, and the head that has some other function. I mean, maybe that head is being grown from that piece of graphene oxide there.
Right.
I mean, that may be a bit in construction, if you like.
Right. So if something is being grown in that way, would that involve DNA instructions or not?
I think it'd just be a chemical thing.
Right.
I think it's a chemical process. These images here look to me like the microbubbles that we saw before that Dr. Campra has seen. They look a bit different because it's a different form of microscopy, I think.
Right.
But they certainly have a similar sort of characteristic to them.
So 5001, we've got blood cells in there all lined up again, as we saw. Is that right?
Well, as we said earlier, we found these microswimmers in the blood. So
this is not a photograph of the vaccine. This is
this
a
is
vaccinated person's blood.
Yeah, and you can see the rouleaued blood, and these particular form of swimmers seem to be created purely from hydrogel, which gives them a soft texture, which enables them to be less harmful within the tissues of the body as they float around the bloodstream. And I think the micronator or something was the name that Mick Anderson found to associate with these, and he found some images of similar sort of structures. I mean, clearly that's not, I don't think, a natural structure, and the doctors who've examined the blood, who've spent decades examining blood, have never seen these kind of structures in blood before.
Right, right. And
the fluorescent nature of that image suggests it's sort of a carbon-based construction.
Right.
And this next image here comes from Dr. Axel Bolent, and again he shows the similar structures in the blood. There, the image on the left is blood before vaccination. The image in the centre is 4 hours after vaccination, so you can begin to see the blood sort of rouleauing, but you can see this hydrogel-based swimmer in that image, and then 1 week after vaccination is the image on the right with the rouleaued blood and a clear image of that swimmer in the blood.
We can assume that that's not the function of what that is, to make the blood do that, even though that's very unhealthy and very dangerous. It has some other function, and a byproduct of which, or a side effect, is it does that to your blood.
Well, I think that the blood's probably been caused by other things like the graphene oxide and electromagnetic radiation, the combination of those. If I had to speculate as to why the blood's rouleaued, I think that just, you know, we're just having to see two particular artifacts there of the injection that maybe are not exactly related. Okay.
So 1004.
So this image here was taken by Dr. Robert Young, and he identified this as a microorganism known as a Trypanosoma cruzi. At the time, he reckoned that it was a Trypanosoma cruzi, but when I read through the literature, I found a paper in which they talked about the Trypanosoma bruzi and having the ideal characteristics to be used as a swimmer, because it alters its shape depending on temperature and on, I think, the viscosity of the fluid that it's in, to have the ideal morphology for moving through that substance. So it may well be a synthetic swimmer, this, designed based on a Trypanosoma cruzi or bruzi.
Right. So they've taken the biology of something that of one of these swimmers, they've modified its DNA and created their own version of it. But when you say synthetic,
I wouldn't like to say how they've created the synthetic object, but they're certainly interested in doing it. They've talked about it specifically in their literature in this one particular paper.
All right, so we've got another image from the Argentinian study here, 18006.
That's right.
And you think that's this payload thing?
Yes, the microbubbles. I think they've identified that as microbubbles.
And possibly also in Pfizer.
Yes, on the Pfizer there as well. They look quite like microbubbles. And then, just to sort of talk a bit more finally about the carbon nanotubes, this is from Ricardo Delgado of La Quinta Columna's video, where he talks about the behaviour of carbon nanotubes and how they react to the presence of something organic, like human breath. And he also described this carbon nanotube as having reddish colour, which relates a bit to the Morgellons, the colouring of Morgellons. Yeah. But if you look at the second image here, you can see that it appears to be connected again to some kind of, I don't know if it's crystalline or some kind of substance at the other end. And again, another carbon nanotube which he showed, and again the final image there shows it's the other end being connected to a crystalline substance which may form some kind of electrode, may have some function along those lines.
So this next bit, you're quite sceptical of this, but it's been suggested by Mick Anderson that this could be what's called a mesoporous carbon sphere, but you're not so sure about that.
Looking at the morphology, it doesn't look sufficiently similar for me to think that was a positive identification.
But if it was, it's used in drug delivery.
Yes. I mean,
so that could be a payload of drugs within the vaccine that could be released at some future point in time.
Yes,
that's what Anderson is suggesting.
Yes, I mean they also have other functions. These mesoporous carbon spheres, for example, they could function as a capacitor. If you look at the actual sphere morphology, I could see that it might be usable as a capacitor, whereas this image here doesn't make me think it looks like a capacitor.
Right. I'll just mention some of my own images now.
Yeah. Okay.
Because, well, I will show a clip of me unpacking one of the vaccine vials and putting it on my microscope first. So just take a look at that. Now today I'm going to examine a COVID-19 vaccine under a microscope. You may remember that I made an appeal for people who can get some samples of the vaccine to send it to me. And recently I received some vials. This is the Pfizer BioNTech vaccine, and somebody has very kindly sent me 3 vials of it. Now I'm going to take my time with this because I'm not an expert with microscopes, but I'm filming it all because I think it's important that you see the entire process of me having received these vaccines. I'll just hold it there for the camera. 1, 2, 3. So this goes under the name Comirnaty, which, as I said, is the Pfizer BioNTech vaccine. I'm just looking to see if there's a date on there. Yeah, it says 6/2022. 6/2022. So I presume that means June 2022. And apparently they dilute these with saline before they actually inject them. 6 parts saline to 1 part vaccine. All right. Now I've got some microscope slides and some cover slips, and also a syringe, so I can take the vaccine out of the vials and put it onto the microscope slide. But I think it's important that we independently look at the vaccines and see what's in there. I'm looking just to see if there's anything anomalous, anything which shouldn't be there. If you look at images of the nanolipids that are alleged to be in the COVID-19 vaccines, they're just tiny little fuzzy spheres which are extremely small, of the order of 100 nanometers across, which you're probably not going to be able to see with a microscope that only goes up to 2,000 times magnification, right? But what you should see is a fairly uniform backdrop. You shouldn't see any rectangular objects or anything like that, which is what people have claimed is in the vaccine. So as I say, I'm wanting to do this just to get independent verification. All right, so I'm just going to take my time and prepare this slide as carefully as I can. But these are definitely unopened vials, because when you take this purple cap off, it snaps. Careful not to get my fingers on any of the poison. So this is a brand new syringe. Right, so we've got the cover slip here, or sorry, the slide. And I'm just going to take a tiny amount out of there. Just pierce the little membrane, there we go, into the bottom. Just suck some up. Okay, take it out. Just drop a little drop on the slide, there we are. Okay, I think that's enough. Okay, on very well. Put that to one side, that's the one that I've used. Okay, cover slip. These are very, very thin. It's easy to pick 2 up by mistake. Okay. Right. Just plonk that straight on top. There we go. Right. Let's take the slide off that I was using. I was just looking at some material earlier on. Okay, and put our slide in. As I say, I'm just taking my time with this because I am a novice. Right, we need to put that on the lowest magnification first. All right, so what did I find? I can show some of the images that I've taken with this 1,000 times microscope. And I did find, in particular, similarities with the Argentinian study. I would say that was the most comparable. Yeah. However, there were images that I took that I also could see in Dr. Camper's images and in other studies. So the images that I've produced convince me that the majority of the studies are genuine. I haven't found any straight-edged items, but perhaps this isn't powerful enough. But one thing that I did do, I observed the strands, the carbon nanotubes, if that's indeed what they are, and I put my microscope to one side. I was there for 5 days. The slide has dried out a bit, and I just so happened to switch it on, and I've recorded movement in a lot of these carbon nanotubes. So we can just take a look at some of my images of these things that appear to have come to life. And I've showed this to a few people, and they've said, "Oh, it looks a little bit like a parasite," but they're clearly not parasites because there's no head, they're just a strand, but they appear to respond. So if I tap them or if I blow on them, then they start moving about. Andersen told me to stimulate them electromagnetically, and he said they would start moving about. I've yet to do that. So if you've had the vaccine, folks, this is what's inside your body, right? And I've proven that. I've proven that with a sealed vial that I've put on the microscope, and I've seen the carbon nanotubes or Morgellons-like strands, whatever they might be, with my own eyes. So just to summarise our own conclusions at this point in time, we believe the evidence for the presence of graphene oxide and carbon nanotubes in most of the jabs is very strong. We cannot say whether quantum automata, nano antenna or self-assembly are present, because the evidence that has been suggested so far could be explained as salt crystals. However, we don't rule out the possibility. It's important to know about these developments in nanotechnology because these developments could be put into jabs covertly. We know that carbon nanotubes can be used for brain modulation, but it is unclear how this could be achieved with the evidence we have so far.